Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of a million suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan – only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies.
Emergency lights are going off, sirens blaring. The spaceship is shaking like crazy. The cosmic darkness beyond the portholes is illuminated by pulsating flashes. The astronauts are strapping themselves in and looking at the screens, cold sweat breaking on their foreheads. Straight ahead, space is cut in half by a blinding beam. Nothing in the universe can stop it. It looks like a humongous airplane jet stream, millions of times more powerful than any jet could make. There's no way to go around it. The leader of the space expedition orders everyone to turn around immediately. That was a black hole jet, a real monster of space. The holes, like huge vacuum cleaners, swallow everything that falls beyond their event horizon, the boundary between space-time and the place where it disappears. If you find yourself close to this border, you're doomed. Even light can't escape the gravity of a black hole, and it's the fastest thing in the universe. The holes not only absorb matter, but also shoot jets into space, mysterious beams thousands of light years long. There are no black monsters near the Earth, but let's imagine if one suddenly popped up close to the Sun. The hole immediately starts devouring the star. Strong gravity pulls one side of the Sun more than the other. The hole tears the Sun into ribbons, eating it just as you would eat spaghetti off your plate. Physicists call this phenomenon spaghettification. When the monster's finished its meal, it hiccups, and, like laser swords, 2 jets cut our galaxy in half. Astronomers are observing a similar catastrophe right now, billions of light years away from us. A black hole from the 3C321 system is bombarding a nearby galaxy with a jet of X-rays, gamma rays, and electrons accelerated to the speed of light. The onslaught has been going on for 1 million years, and we're lucky it's taking place at a safe distance. If a jet comes close to a planet similar to Earth, it'll vaporize the atmosphere and the ozone layer. All life on the surface will disappear. Only deep underground dwellers will survive. If a black hole does appear next to the Sun, though, we won't live long enough to see the jet. The monster will absorb the energy of the star, and we'll simply lose all heat and light. The Earth will cool down, delving into eternal darkness. But, like anything else, jets can do good things too. Like fertilizers helping crops to grow, the energy of the rays squeeze the space clouds, and new stars will be born from them. Imagine a drain in the bathroom through which water flows into a pipe. The water moves in a spiral, and some of it rotates around the hole. Now imagine that the black hole is the same drain, and instead of water, there's the stuff called plasma. It spins rapidly, gets magnetized, and collects into a huge accretion disk. Plasma starts to glow, and at some point shoots 2 streams into space. The black hole V404 Cygni lies 8,000 light-years away. It's like a firework display that weighs as much as 10 suns. The problem is, they forgot to install it securely, and the wick was prematurely set on fire. The hole is powered by gas from a nearby star. It provides infinite charges for the space fireworks. The V404 Cygni jets don't just fire from the poles, but in every direction. A disk as wide as 7 suns is spinning around the black hole. The inside of the disk is wobbling like a top that's about to stop spinning and fall. Scientists believe the wobbles and random shots are caused by distortions of the space-time continuum. Black holes are not the only ones who know how to put on a space show. Their main competitors are gamma-ray bursts. Science doesn't know exactly how they appear. Most likely, it's because of the decay of a huge star or the collision of neutron stars. Satellites record one gamma-ray burst every day, but at least 500 outbreaks occur in the universe within the same time period. An amateur astronomer first seeing the observable universe may feel like a movie star on the red carpet. Only they'll be blinded not by the lights from the cameras of journalists and fans, but by constant gamma-ray bursts. If there is a flash near the Earth, our planet will feel like a candle in a snowstorm. Imagine that you live in the future and can take off on safe interstellar flights. On your spaceship, you fly to a planet that looks like Earth to see a gamma-ray burst with your own eyes. Your ship is cutting into outer space and landing on the planet in question. As soon as you step on its soil, though, you feel it. Every living thing in this world is waiting for something terrible to happen. Frightened birds are flying through the sky. Animals start running out of the forests and looking for shelter. The wind makes the leaves rustle, and it's like they're whispering to you, "Save yourself, get out of here." Then, the wind grows stronger and turns into a storm. A bright flash appears on the horizon. After a few seconds, the light intensifies. Someone huge has turned on space floodlights. Everything is lost. There is only light. As much energy is released in 1 second as our sun generates in 10 billion years. 10 seconds pass and the show is over. The planet is moving through space, and the flash has only hit a part of its southern hemisphere.
For a star, running into a black hole normally ends in a spectacular light show and its destruction. Just one star that astronomers know of managed to survive an encounter with a black hole as heavy as 400,000 suns. It happened in a galaxy about 250 million light-years away from Earth. Astronomers with really powerful equipment noticed bursts of X-rays that raged in space every 9 hours. They thought they must be Mayday signals from a star trapped by a cosmic abyss. The star was an average red giant when it met its new friend for the first time. When they got too close to each other, the hungry space monster couldn't resist the temptation and snacked on its guest. When it was done with the star's outer hydrogen layers, all that was left was the star's core. Eventually, the poor thing turned into a white dwarf. But for some reason, the giant space monster couldn't finish the meal and trapped it in its orbit for later instead. Ever since, the now white dwarf has been traveling in 9-hour laps. It stays far enough from the hole so it won't fall in or get swallowed. Its journey isn't going super smoothly. Because of gravity, the orbital path is constantly rotating. After 2 days, it resembles a spirograph pattern. As the black hole keeps snacking on it, the star keeps losing its mass and growing in size. Its own orbit is becoming more and more circular. Scientists believe one day it will be able to spiral away from its mean friend and turn into a planet the size of Jupiter in 1 trillion years. That's 70 times longer than the universe has existed so far, so it might not ever happen. The Milky Way alone has hundreds of millions of black holes, and there are way more beyond it. They might feed on other stars and release them in other galaxies. The telescopes that exist now might not be strong enough to spot them. Most galaxies, including our Milky Way, have supermassive black holes at the center. They can be billions of times heavier than the Sun. Others of their kind are only 3 times the mass of the Sun. The nearest black hole to the Earth was spotted 1,000 light-years away, just around the corner in galactic terms. It's in a star system you can see with an unaided eye. Scientists found it when they noticed a star behaving weirdly. It was a giant, rotating like crazy. They guessed it must have a powerful gravitational companion. The hungriest black hole astronomers have spotted so far weighs as much as 34 billion suns and is about 6 times bigger than the one at the center of the Milky Way. It eats the equivalent of 1 sun every day. Sometimes black holes even devour others of their kind that happen to be too close to them. Before you get on a spaceship to escape to some safe, no-black hole galaxy, here's some good news. Even though they're supermassive, they don't have a radius large enough to destroy Earth. And even the hungriest of them are safe to watch from a distance. No black hole should come closer to our planet than the Sun for as long as the universe has existed, multiplied by 10 billion times. In the unlikely case one of these scary things passes by Neptune, it could affect the Earth's orbit. That would be no good. In theory, anything can turn into a black hole. The only difference between it and the Sun is the material their centers are made of. It's incredibly dense in those huge space monsters. In reality, there's just one known way to make a black hole. It has to be the gravitational collapse of a supermassive star, 20 to 30 times the mass of the Sun. So, the Sun will never ever become a black hole. If it happened, though, and the former star retained its mass, it would still have the same gravitational power. Earth would still keep going around it and wouldn't get pulled in. Its orbit would also remain as it is. The only huge problem would be the lack of sunlight. In reality, the Sun isn't massive enough for such a transformation and will eventually become a white dwarf. A black hole won't ever eat an entire galaxy for lunch. There are about 400 billion stars inside the Milky Way. Just around 0.1% of all the stars that will ever form will end up becoming black holes. The ever-hungry supermassive monster, located right in the middle of a galaxy, has an impressive gravitational reach. But even that wouldn't be enough. It has already eaten most of the stars that were close to it. It already weighs like a few million suns, so it can't grow much larger even if it keeps snacking on sun-like stars. Galaxies will keep bumping into each other, and black holes will keep growing and merging. But because the universe is already huge and keeps expanding, these collisions and mergers won't go on forever. Black holes will travel this huge space like rogue stars. They won't even be able to eat the dark matter on the outskirts of galaxies. Eventually, all the black holes will perish, but that would be a long, long time from now. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.